Your phone says it has 1% left. That sounds precise. 1 out of every 100 units of energy remains. A tiny, measurable slice of the battery is still full. Except your phone cannot actually look inside a lithium-ion cell and see how much charge is left. There is no float, no transparent tank, and no sensor that directly reads 1%. The number on the screen is an estimate. And underneath that simple number is a small prediction system constantly trying to answer a surprisingly difficult question. How much usable energy can this battery still deliver? Start with the obvious clue. Voltage. As a battery discharges, its voltage changes. So in principle, the phone could measure voltage and translate it into a percentage. But a lithium-ion battery does not behave like a perfectly straight fuel gauge. Across much of its useful range, the voltage curve is relatively flat. A small voltage difference can represent a much larger change in state of charge. Worse, the voltage you measure depends on what the phone is doing. Launch a game, turn up the screen, or start recording video, and the heavier load can pull the terminal voltage down. Stop the task, and the voltage may recover. Temperature changes it too. So voltage is useful, but voltage alone is not enough. The second clue is current. Inside the phone, a fuel gauge chip can measure charge flowing into and out of the battery. Engineers call this Coulomb counting. If the battery begins with a known amount of charge, the system can subtract what the phone uses and add what the charger puts back. It sounds simple. Start with a full bucket and count every drop. But the counter is never perfect. Tiny measurement errors accumulate. The phone also needs to know the real size of the bucket, and that size does not stay fixed. A new battery might hold close to its designed capacity. After hundreds of charge cycles, chemical aging reduces what it can store and how much power it can deliver. Heat accelerates wear. Code can temporarily reduce available performance. A demanding task can expose limits that do not appear under a light load. Now 50% has two moving parts, half of what and under which conditions. This is why modern battery gauges combine clues. They watch voltage, current, and temperature. They use a model of how that particular cell chemistry behaves. They compare what the model predicted with what the battery actually did. Over repeated charge cycles, the estimate can be corrected as the battery ages. In other words, the phone is not reading a level. It is maintaining a belief. That belief can drift. Imagine the current sensor is off by only a tiny amount. For a few seconds, it hardly matters. Add that error over hours of charging and discharging, and the estimate slowly moves away from reality. The system then looks for opportunities to correct itself using voltage behavior, periods of rest, and known points in a charge cycle. That is recalibration, not changing the chemistry inside the battery, but improving the software's estimate of it. Apple has publicly documented cases where its battery health reporting system had to recalibrate inaccurate estimates over several weeks of normal charge cycles. The battery itself was not necessarily worse. The reported model of the battery was wrong. The same basic uncertainty explains several familiar moments. Sometimes 1% lasts much longer than expected. Sometimes a phone shuts down before the display reaches 0. Sometimes the percentage changes after a restart, after charging, or after moving from a cold environment to a warm one. These are not all proof of a defective battery. They can be the estimator reacting to new evidence or discovering that the battery cannot deliver the power the phone is demanding under current conditions. Think of it like a car's miles remaining display, but in a much smaller and more chemically complicated system. The estimate depends not only on what is stored, but on how quickly you are using it, the condition of the storage system, and the environment around it. This also explains why battery percentage and battery health are different numbers. Battery percentage asks how much usable charge is estimated to remain right now. Battery health asks how much capacity can this aging battery hold compared with when it was new. A worn battery can still report 100%. It means 100% of its current estimated capacity, not a return to its original factory capacity. So should you ignore the number in the corner of your screen? Number, it is still extremely useful. The system hides a messy electrochemical problem and gives you a number simple enough to act on. Just do not mistake simplicity for certainty. Your phone does not know the remaining charge in the way a ruler knows length. It observes imperfect signals, runs a model, updates that model, and gives you its best answer. The clean percentage is the interface. The uncertainty is what lives below it.